Okay, we have a continuous random variable x has a probability density function given by f of x's kx between 0 and 4, with 0 otherwise. And now we're going to have to find the value of the constant k, find the value of mu, which is the mean, find the value of sigma, which is the standard deviation, find the expected value of 3x minus 2 and the variance of 3x minus 2, find the probability that x is greater than the mean, and find the probability that x lies with the mean minus 1 standard deviation and the mean plus 1 standard deviation. So for a PDF, the integral of all f of x dx is equal to 1. And then if we integrate that between 0 and 4 of kx cubed, dx is equal to 1. That becomes kx to the 4th over 4th between 0 and 4, which is equal to 1. Substitute the limits in. K 4 to the 4 divided by 4 minus 0 to the 4 divided by 4. Don't always assume if you substitute 0 and you get 0. It's equal to 1. 4 to the 4 divided by 4 is 64, so we get 64k is equal to 1. This is actually equal to 0, therefore k is equal to 1 over 64. So if you write out f of x, we get 1 over 64x cubed between 0 and 4, and 0 otherwise. Here is a graph of it, and actually here I have a GeoGebra applet which I'll attach to this video, where you can use it to find probabilities. By moving the sliders, you can get different probabilities, and you can actually use the sliders to show the answers to the previous part. If you want to, you have to do arrow keys to get the smaller values. Again, I'll attach this to the notes of this video. So find the mu is e of x, so to do that you have to do the integral of all x of x times f of x dx. So we need to do integral from 0 to 4 of x times x cubed over 64 dx. When I say here you have to do all of x, so that means the area where it's defined. So it's 0 to 4 of x to the 4 over 64, x times x cubed gives you x to the 4. Integrating, you get x to the 5, and then 5 times 64 is 320 between 0 and 4. Putting in the limits, 4 to the 5 over 320 minus 0 to the 5 over 320, and that gives me 16 over 5, or 3.2. To find the find the standard deviation, first we have to find the variance of x, and that's equal to e of x squared minus the mean squared. The mean squared is that squared, or e squared of x. So e of x squared is equal to the integral for all x of x squared times f of x dx. E of x squared is equal from 0 to 4 of x squared times our function x cubed over 64 dx. So part of these sort of questions is setting up the integral correctly before actually integrating. So it's 0 to 4 of x to the 5 over 64 dx. Integrating, like 6 to the x to the 6, and then 6 times 64 is 384 between 0 and 4. Putting in the limits, we get 4 to the 6 over 384 minus 0 to the 6 over 384, which gives 32 over 3. That's just finding e to the x squared. The variance of that is e to the x squared, which minus the mean. So the variance of x is going to be 32 over 3 minus the mean, which is 16 over 5, all squared. That gives you 32 over 75. Now to find the standard deviation, you have to take the square root of that. The standard deviation is the square root of the variance. So it's the square root of 32 over 75. Like I said, the standard deviation is the square root of the variance. If you do this on one of these calculators, it will give the answer 4 root 6 over 15, or the decimal equivalent of 0.653 to 3 significant figures. Right, we now have to do e of ax plus or minus b. This is called expectation algebra, so we need to do, this means the same as doing a of e of x plus b plus or minus b. So that's going to be e of 3x minus 2, which is equal to 3e of x minus 2, which is going to be 3 over times 16 over 5 minus 2, which gives you 38 over 5, or 7.8. For the variance of ax plus b, that's just equal to a squared times the variance of x. So give me the variance of 3x minus 2 is just going to be 3 squared times the variance of x, which is 9 times the variance of x. So it's going to be 9 times the variance of x, and the variance of x was 32 over 75, which gives me 96 over 25, or 3.84. The probability that x is bigger than the mean is going to be the probability that x is greater than 3.2. So we have to integrate the function from 3.2 to 4 of x cubed over 64 dx. That gives me x to the 4 over 256 from 3.2 to 4. 4 to the 4 over 256 minus 3.2 to the 4 over 256 gives me 369 over 625, the exact answer, or 0.590 to 3 significant figures. With the GeoGebra applet, you can get the answer to 0.95904, like that. To get the decimal places, you need to perhaps use the arrow key. Now we want the probability of 1 minus the standard, the mean minus the standard deviation. To x less than the mean plus the standard deviation, which is going to be the probability of 3.2 minus 0.653, x greater than that, and x less than 3.2 plus 0.653. So it gives me the probability between 2.547 and 3.653. So I need to integrate the function between those two values, 2.547 and 3.853. Integrating, we get x to the 4, same limits, substituting in the limits, and then working them out using our calculator, we're just going to get 0.69651, which is 0.697 to 3 significant figures. Again, using the GeoGebra applet. Now, to get the more decimals using the GeoGebra applet, you need to use the arrow keys on your computer to generate these. So go to 2.5, then get 4, and then get 7. And the same here, 3.85, and then get 3, and you'll get the same answer as we've got here. Okay, so this has been a video to show you how to really find the mean and the variance from a continuous random variable. I hope you've understood, and I thank you very much for watching.